Hello, my dear students. This is Ikhlaq Sir Physics. So, my dear students, we are going to discuss another beautiful problem of the electrostatics. Okay, it's rather electrostatics come simple harmonic motion. Okay, now what the question is exactly is this: this is a charged ring, a uniformly charged ring. Okay, the charge of this ring that's equal to plus Q, and the radius of this that is given to you that's equal to A. All right. Okay, this is a ring. Now, at the center point of this ring, a charged particle whose charge is equal to minus q, negatively charged particle is placed. Okay. Now, the first question will be what's the net force on this small q, this charged particle which is placed at the center? The answer is obviously it is 0. By symmetry, the net force on this minus q that will be equal to 0. Okay. Now, what is the question? Let's have a look on the question. The question is like this: charged particle, this charged particle, it is slightly displaced from its equilibrium position. Okay, when it's slightly displaced from the equilibrium position from the center of this ring, calculate omega. That means you will have to calculate the angular frequency and the time period of the particle. So number one, we are supposed to calculate the angular frequency, and number second, we are supposed to calculate the time period of the particle. Okay, the first thing I will do is that I will displace this charged particle from the equilibrium position. So that's what I have done, is that I displaced this charged particle from the center. When I will displace the charge particle from the center, now is there a net force on the charge particle? The answer is big yes. Now there's a net force on the charge particle, and that will be equal to F. And that F, see that since this is positively charged ring, this is a negatively charged particle, the force will be attractive in nature. Attractive means that it will be directed towards the center of this ring. Okay, and that's the first good news for the simple harmonic motion. Okay, अगर आपको याद होगा, आपने क्लास 11th में सिंपल हार्मोनिक मोशन पढ़ा होगा, वहां पे आपने पढ़ा होगा व्हेन एवर अ पार्टिकल एक्सिक्यूट सिंपल हार्मोनिक मोशन, there must be a net force on the particle, and that net force must have two important properties. Number one is that this force must be always directed towards the mean position, towards the equilibrium position. Number one. Number second is that this force must be a linear function of the displacement. We will calculate this force and we'll try to see whether it's a linear function of displacement or not. Okay, that will be the first thing to do. Okay, now what is the displacement? That's equal to x. And then see in the question is like this: it is slightly displaced from the center. Slightly displaced, what does that mean? That means this x is very small compared to the a, compared to the radius of this. When this x is very small, so easily what we can do is that we can easily replace this r by a. Approximately we can write down this r is equal to a. This approximately r is equal to a. All right, so we are going to calculate the force. Before calculating force, I will write down what is the electric field due to the charged ring. वो आपको याद होगा, इलेक्ट्रोस्टैटिक्स में आपने पढ़ा होगा. What is the electric field due to a charged ring? That's like this: electric field comes out to be K, capital Q, multiplied by x divided by r cube. Okay, where r is the slant height, this distance, this is r. So this is the electrostatic field, and it is the electrostatic field due to the ring. Okay, now see that x is very small compared to a. In that very case, this r will be approximately equal to a. So this is equal to k q x divided by, here I will write down what, a cube. Okay, now I know the electric field at this very point, this point p. This is the point p. I know the electrostatic field at the point p. Can I calculate the force on the charged particle? Yes, I can. How I can calculate the force on the charged particle? Force is simply equal to charge multiplied with the electrostatic field. So let me write down that equation. So the force on this charged particle, that comes out to be Q multiplied by electrostatic field. Now substitute the value of electrostatic field. It comes out to be K, capital Q, small q, divided by a cube multiplied by what? Multiplied by x. Now see, there's the second good news for you, and that is this force is a linear function of displacement, and that's actually what we want. This force must satisfy two conditions. Number one is that it must be directed towards the mean position. It is directed towards the mean position. Number one. Number second is that it's a linear function of displacement. Okay. Now what this force will tend to do is that it will tend to bring this charged particle minus q back to the equilibrium position. Okay. The reason is that force is directed towards the mean position. But once it reaches the mean position, what's the net force on this charged particle? It's equal to 0. But it will not stop at the mean position. It will have some momentum, it will have some velocity. Because of that momentum or because of that velocity, it is going to overshoot the mean position. And it will reach somewhere here. So this is the charged particle here, somewhere here, minus q. Again, there will be the force on this charged particle. Again, that will be directed towards mean position. So see that this force is always directed towards the mean position. And hence this force is responsible for the simple harmonic motion of this charged particle. Okay. Now, next, what we are supposed to calculate is the angular frequency and the time period. How I am going to calculate that? I know the generalized equation for the force in linear SHM, and that is like this. That is like this. M into omega square multiplied by x. ये इक्वेशन हमने पढ़ी है बेटा SHM simple harmonic motion unit number last of the class 11. Now what is this M? It's the mass of particle. What is this omega? It is the angular frequency of the particle. And what is this x? It's the displacement from the mean position. All right. So in this very equation, this x and x is going to cancel. When that will cancel, I can easily calculate the value of omega, which comes out to be root of all this. That is k capital Q. This and this is going to cancel. K capital Q small q divided by m into a cube. And what about time period? टाइम पीरियड किसके बराबर होता है? वो होता है 2 पाई डिवाइडेड बाय ओमेगा. सो 1 by omega is the reciprocal of this, which is m into a cube divided by k capital Q small q. Okay, so eventually we are able to calculate the frequency, angular frequency, and the time period of the charged particle. I'm sure that this problem will amaze you a lot. Okay, and the next session will be back with one more mesmerizing problem in physics. See you then. Take care.